Hello everyone, this is a one short revision on electrostatics and electrodynamics. Okay, and we have done one short revision of um, quantum and thermodynamics and statistical mechanics. So this is another one. This is electrodynamics or electromagnetic theory. One short revision. Like not everything we can revise, but whatever important we can revise in this video. Okay, so first of all. First of all, let's write the basic equation like del dot equation of continuity. Del dot E is equal to rho by epsilon naught, and E we know E is what minus like minus grad of V, right? Del square V is equal to 0. This is your Laplace equation. Laplace equation. Okay, and del square V is equal to minus rho by epsilon naught. This is the Poisson's equation. Okay, charge density is 0, then this equation becomes 0. Alright, yeah. Yeah. Then the Poisson equation is like del square V is equal to minus rho by epsilon, right? So suppose you have to write this in spherical coordinates, spherical polar coordinates. How will you write spherical? How will you write del square in spherical coordinates? Hmm? 1 by r square del by del r square del by del r of v is equal to minus rho by epsilon. Yeah, yeah. 1 by r square, it's like this, del by del r of r square del v by like minus rho by epsilon. Okay, just have to do this way. Energy for continuous charge distribution, energy for continuous charge distribution. Energy is what? U is equal to epsilon naught by 2 E square dV. Epsilon by 2 A square E square dV. Okay. Yeah. Potential energy formula is what? Potential energy is 1 by 4 pi epsilon naught Q1 Q2 by R. Yeah, alright. Now let's go into multiple expansion, which is another important topic here. Is multiple expansion. Multiple expansion. Okay. So we know the potential due to dipole will be potential due to dipole. Potential due to a dipole is V is equal to 1 by 4 pi epsilon naught P cos theta by R square. This is the potential due to a dipole. Okay, P cos theta by R square. Electric field due to dipole is electric field 1 by 4 pi epsilon naught P by R cube. Okay, 2 cos theta R cap plus sin theta R cap. 2 cos theta R cap plus sin theta R cap. E is equal to 1 by 4 pi epsilon naught P by R cube 2 cos theta R cap plus sin theta R cap. Just remember this formulas. B is equal to 1 by 4 pi epsilon naught P cos theta by R square. E is equal to 1 by 4 pi epsilon naught P by R cube 2 cos theta R cap plus sin theta R cap. The potential energy is potential energy of a dipole. Potential energy of dipole U is equal to minus P dot E. That's what you think, okay. Torque is tau is equal to P cross E. Okay. 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 Now monopole moment. Monopole moment. Summation n is equal to 1 to n Qn. Okay. Now just the summation of all the charges. Dipole moment. Dipole moment is summation n is equal to 1 to n Qn R n. Sorry. Qn R. Okay. So your suppose there are some poles and what is the potential and we write pole and this is a potential. This is your electric field. We'll write the dependence. Okay. So monopole is inverse proportional to R and is proportional to R square. Dipole is it will go on like this. Okay. You can see a pattern. You can remember that way. Quadrupole. You can see there is a pattern here. Okay, you can memorize it that way. You have done numericals based on knowledge. Okay, so I hope you watch those videos. The polarization formula for polarization is charge polarization. Okay, not that polarization. Induced dipole moment, induced dipole moment, all divided by volume. So Q into T divided by into T, so that is Q by N. So polarization is Q by N. Bound surface charge density now. Formula for bound surface charge density. Bound surface charge density is sigma b is equal to polarization dot n cap. Okay. Bound volume charge density. Bound volume charge density. Bound volume charge density. That will be rho b is equal to minus del dot polarization. Remove this formulas. Now Gauss law in dielectrics. Gauss law. Gauss law in dielectrics. D is equal to epsilon naught E plus P. This is called differential form. Okay. D dot ds is equal to qf. This is called integral form. Okay. Now displacement vector D is equal to epsilon E. P is equal to epsilon naught chi E. It's E vector. For free space, your chi E is 0. For free space, chi E is 0. So, the P is 0. Is that alright? So let's come to capacitance. Sorry, capacitance. So capacitance, we know formula is epsilon naught A by D. Okay. Spherical capacitor, what is the formula? Spherical capacitor. Spherical capacitor is what is the formula? C is equal to 4 pi epsilon naught R. Okay. Suppose there is a conducting slab between two capacitors. Okay, its thickness is T. Hmm. So it will be capacitance will be epsilon naught A by T minus T. Okay. And, here this is a conducting slab. Okay, this is a not a dielectric slab. This is a conducting slab. Okay, where this electric field is zero inside this. If there is a dielectric slab, there is a dielectric slab. Okay, there is a dielectric slab. So dielectric slab. This is your and, E is equal to E naught by K. Okay, so your D, so T. So C is equal to epsilon naught A by T plus T by. Right. Now energy of capacitor. Why T by K? Because this is like by K. K will be divided because this is dielectric. Right. D minus T is this region. The space region is D minus K T, and this region is D by T by K. Okay. Energy of capacitor. What is the energy? U is equal to half into QB. It can also be written as Q square by 2C. So written half C square. Okay. Is that alright? Now let's come to method of images. Method of images. So number of images is n is equal to 360 by theta minus 1. This value should always be odd, okay? We can calculate the force between charges also, okay, no problem. Hmm. Like there will be conducting slab, there will be plus q here at a distance d, so there exactly minus q charge will be here at a distance d, okay? For example, it's like this, it's conducting slab, there is this charge, there's another charge, so there will be another charge here, another charge here also, so you have to calculate force between them. Okay, I hope you can calculate all of that. Wait. Then grounded conducting sphere, grounded conducting sphere and point charge. Okay. So grounded conducting sphere here your q dash will be what? Remember the formula minus r by a q, and your b will be your r square by a. You have to remember these two. This is the magnitude of image charge. This is the position of image charge. Okay, is that all right? Next, boundary conditions. Next is your boundary conditions. Boundary conditions. So, what are the boundary conditions? E above minus E below is equal to sigma by epsilon. Okay, this is now E parallel minus E below is equal to, okay, D above minus D below is equal to 0, and D parallel above minus D parallel below, that is your what? D parallel above polarization minus parallel. Is that alright? Okay. Next, write an important form like point. The potential source continuity, but its first order derivative does not. But its first order derivative, but its first order derivative does not. Okay. That means v above minus v below is equal to 0, but del v above by del n minus del v below by del n is equal to 0. Sorry, is not equal to 0, is minus sigma by 7. So this is your continuous, this is your discontinuous. Is that alright? So parallel components of electric field are same, but perpendicular components are not same. That's like, for example, it's here like this: 2 I cap plus 3 j cap minus 3 k cap. Epsilon 1 is 2, epsilon 2 is 3. So this is your z is equal to 0. Z is equal to 0 means xy plane. Like x, no, z is equal to 0 means xy will be constant. So you can blindly write 2 I cap plus 3 j cap. Okay, but the third component will be what? It will be this minus 3k cap into epsilon 1 by epsilon 2. Simple as that. Okay, minus 3 into 2 by 3. Don't need to think too much, just do this. That will be the answer. Okay, yeah. Epsilon 1 into epsilon 2. Epsilon 1 into epsilon 2. Epsilon 1 by epsilon 2. Is that alright? Is that all right? Okay, next comes to magnetism. Magnetism, we know the formulas like magnetic field for straight wires like mu naught by 4 pi, mu naught I by 4 pi r, sin theta 1 plus sin theta 2, sin theta 1 plus sin theta 2. Hmm. This is for straight wire. For example, this is a uh, this one. So B is equal to mu naught I by 4 pi r, and this will be your phi. Pi is a what? This angle. This pi is in radian. Okay, not in degree. So in Ampere's circuital law, Ampere's circuital Ampere's circuital law is BDL is equal to mu naught I enclosed. BDL and mu naught I enclosed. Okay. Next is a magnetic field due to solenoid. Magnetic field due to solenoid is like B is equal to mu naught Ni by 2 cos theta 2 minus cos theta 1. Okay. Cos theta 2 minus cos theta 1. Okay. Uh, so for example, the magnetic field due to toroid, right? A magnetic field due to toroid. What is a toroid? Like this. This will be the loops like this. Okay. So B in is 0. Okay. B out is 0. But here B is not 0. So B will be what? B will be mu naught Ni by 2 pi r pi cap. So the formula. Okay. Next, the ones easy ones I'm not gonna write these formulas like R is equal to mv by qb, all those things, right? Cyclotron and all. Like R is equal to mv by qb. You know how it came. Mv square by R is equal to qbv. Those things. Okay, leave it. These are very basic things. Okay. For helical motion of particle, the pitch is called pitch is d is equal to b parallel into t. That is b cos theta. T is your 2 pi m by qb. Yeah, yeah, 2 pi m by qb. Okay. The magnetic moment you know is m is equal to ia, and the direction is south to north. Okay. Yeah. And m by l is equal to q by 2 mu. This one very important one. This is mass per like, okay. Angular moment and angular momentum. Angular moment by length is equal to q by 2 mu. Okay. Now is your you can write your vector potential A is equal to half B cross R. Okay. So B is given and you are asked what is A. Vector potential due to magnetic dipole. Vector potential due to magnetic dipole will be magnetic dipole BA is equal to mu naught by 4 pi m sin theta by r square pi cap. M sin theta by r square pi cap. Okay. So B we know is B is what del cross A, right? And A is what? Yeah. Okay. There is another formula right on del cross A cross R, where A is a constant vector. Okay. This is 2A vector. Hmm. So these things might come useful someday. Okay. Yeah. Okay. Boundary condition for magnetic field is set. Boundary conditions. Okay. Boundary conditions. Boundary conditions B perpendicular above minus B perpendicular below is 0. This is continuous. Okay. But B parallel is the opposite of that related field thing. B parallel above by B parallel below is equal to mu naught K. This is your discontinuous. Okay. H perpendicular above minus H perpendicular below is equal to M perpendicular above minus M perpendicular below. Hmm. Next is H parallel above minus H parallel below is equal to 0. We know B is equal to what? B is actually mu H. Yeah. Yeah. Next is electromagnetic induction. This chapter is also an easy one. Electric, this is EMF is equal to minus del phi by del t. We know EMF can also be written as BBL. Okay. And current is E by R. That is BBL by R. Right. It can also be written as this being dr. Hmm. Okay. Then there is E is equal to minus LDI. This is your self inductance. Energy of inductance half Li square. L can also be written as phi by I. Right. Now let's write the Maxwell equations. Maxwell's equations, which are very important. First of all is del dot E equation of continuity. If del dot E is rho by epsilon naught. Yeah, this is your Gauss law. Okay. Now del dot B is 0, that implies that magnetic monopoles don't exist. Del cross E is equal to minus del V by del T. Okay. And your final one is del cross. This is for electromagnetic field. Okay, electrostatic field for electrostatic del cross E is 0. Hmm. So del cross B, remember this the final one, mu naught J vector plus mu naught epsilon naught del E by del T. Okay, this is Ampere's law of electrodynamics. D we know D is a displacement vector is this, and B is this. Okay, is that all right? Properties of Maxwell equations. Hmm. Equation of continuity is what? Equation of continuity is del dot J plus del rho by del T is equal to 0. Is that all right? Okay. Another equation write down. So maybe come in handy. Del square E by del 1 by C square del square E by del T square is equal to 0. Okay. And del square B minus 1 by C square del square B by del T square is also equal to 0. Okay. We can also write formulate B is equal to K cross E by omega. Okay, E is equal to minus E square by omega K cross B. Just remember these two formulas. This question will surely come from these two. B is equal to K cross B is equal to what? K cross E by omega. E is equal to minus C square by omega K cross B. Surely question will come from this. So yeah, I better do it. Now there is pointing vector. Pointing vector. Pointing vector is S is equal to energy by area into time. Okay. So power by area. Energy by time is power by area is there. S is equal to P by A. Hmm. So S is also equal to E cross P by mu. That is E cross H. Okay. Is that alright? Average energy density is average energy density U is 1 by 4 epsilon naught E square. Okay. This is the average of electric field. Average energy magnetic field is also 1 by 4 epsilon E square. But average of the electromagnetic field, average of the energy of electromagnetic field is half epsilon E square. Okay, that's right. Okay. Average pointing vector is called intensity. Okay, intensity, that is E cross B by mu naught. Okay, if I write it, I can write the EV by mu naught. Okay, C epsilon naught E square. Can write that also. So I is equal S is equal to I is equal to C epsilon naught E square. Just remember this formula. Half C epsilon naught E square. Okay. Now radiation process I by C is the like for completely absorbing system, and 2I by C is for completely reflecting system. Completely reflecting system. Okay, completely reflecting system. Now impedance of EM wave, impedance of EM wave, impedance of EM wave is what Z naught is equal to E naught by H naught. Okay, E naught by B naught by mu. E naught by B naught is C. Okay, so mu naught is C. Okay, mu naught C, because we know E naught is equal to B naught C. Is that right? Okay. Z naught can also be written as mu naught by epsilon naught root overs. Alright. I hope you can solve these questions. Alright. Now refractive index. This is the formula refractive index. Refractive index. Refractive index mu n. So let's write n. N is equal to mu bar epsilon r. Okay, just remember this. Okay, this impedance can also be written as 125 mu r epsilon r. Okay. So del square E minus mu, remember this one, del E by del T minus mu del square E by del T square is equal to 0. Del square V minus mu sigma del V by del T minus mu epsilon del square V by del T square is equal to 0. Another formula, relaxation time tau is equal to epsilon by sigma. Okay, remember this one. Okay. Now let's revise a bit of polarization. Polarization. See if pi is equal to 0, pi, 2 pi, etc. This is your plane polarized. Okay, plane polarized. But if pi is equal to pi by 2, 3 pi by 2, etc., we have to then check the amplitude. Okay, if the amplitudes are same, either two, if the amplitudes are same, this is your circularly polarized. This is your circularly polarized. If the amplitudes are different, this is your what? Elliptically polarized. As simple as that. Elliptically polarized. So we have to check first the phase difference. Phase difference, if it is 0, pi, 2 pi, etc., this is plane polarized. If phase difference is in the order of like 90 degrees, like pi by 2, 3 pi by 2, etc., we have to check the amplitude. Okay. And if the amplitudes are same, then it's circular polarized. If the amplitudes are different, it is elliptically polarized. Next is a Brewster angle. Brewster angle. Theta b is equal to tan inverse n2 by n1. Okay. Malus law it is equal to I naught cos square theta. Reflection coefficient R is equal to n2 minus n1 by plus n1 whole square. Transmission coefficient T is equal to 4 n1 n2 by n1 plus n2 whole square. R plus T will always be equal to 1. N2 minus n1 whole square by n2 plus n1 whole square. Transmission coefficient is 4 n1 n2 by n1 plus n2 whole square. So this question comes very repetitively. There are three polarized light goes through this, something. So what is the final intensity emerging from it? So this one, just remember, I final will always be I naught by h sine square 2 theta. Okay, I naught by h. Next is the transmission line. We have done this in a video, separate video. You can check in the playlist. Transmission line. So for for two wire line, this is two wires. So transmission is coefficient C is equal to pi epsilon naught by ln 2d by d. Okay, for coaxial cable, coaxial cable like this. Okay, capital D. This is your for cable. C is equal to 2 pi epsilon naught by ln d by d. Okay, there is no 2 here, but there is 2 here. Okay. Next is your characteristic impedance, and J naught is equal to characteristic impedance R plus j omega L by G plus j omega C. Now, low loss condition. What is your low loss condition? Low loss condition is your R is equal to 0, G is equal to 0. If R is equal to 0, G is equal to 0, J naught is equal to how much? J omega L by j omega C, which is your L by C. This is called what? Low loss condition. Now, distortion loss condition. Distortion loss condition is what? R by G is equal to L by C. Even if you do that, still you will get L by. Is that right? Next is called a thing called propagation coefficient. Propagation coefficient. So propagation coefficient is what? Gamma is equal to R plus j omega L H plus j omega C. So gamma is equal to j omega root over of LC. This is called low loss condition. Then distortion loss condition is, here the thing is what? R is equal to G is equal to 0. Distortion less condition is R by G is equal to L by C. Right? Distortion. So that will be gamma is equal to root over of LC if you put all the values R by L plus J omega. Okay. Next is your waveguide. Waveguides. So waveguide. Now rectangular waveguide transverse electric mode is called TEM. Transverse electric mode TEM. Condition is Ez is 0. When electric mode is there, Ez is 0. Bz not is 0. Just remember that. When electric mode, Az is 0. So Bz is what then? Bz is B naught cos m pi x by a into cos n pi y by b. Just remember this. M pi x by a into n pi y by. Okay. Now transverse magnetic mode TM. Magnetic means a magnetic will be 0. Magnetic transverse magnetic mode, that will be what? Here Bz or Hz will be 0, but Ez will not be 0. So Ez will be then how much? E naught sine m pi x by a sine n pi y by b. Here it is sine, here it is cos. Is that alright? Next is the Gauss and Lorentz transformation. From here also questions come. Gauge and Lorentz transformation. So B is equal to del cross A, E is equal to minus del phi minus del A by del T. Minus del phi minus del A by del T. Yeah. So Gauss transformation is A dash. In place of A dash, we put what? A plus del lambda. So phi dash, we put what? Phi minus del lambda by del T. Just remember that. A is A plus del lambda, phi minus del lambda by. Okay. formula to E square minus B square is your Lorentz invariant. Next is your radiation. Radiation E is proportional to 1 by R, B is proportional to 1 by R, but S is proportional to mass. Pointing vector. Okay, remember that. Okay. So I hope you wrote all the formulas. These are the formula. I have only written the formulas and all concepts and all which you guys from like numericals. You also see how to solve those numericals and all. Okay, and I hope it will help you in your last minute preparation for GATE. Okay, thank you very much. All the best for your exams. Thank you.